Let's look at some more examples of the chain rule. Okay, number one, let's start with, how about 2x cubed minus 4 all to the 4th power. Okay, so let's say this is y and we need dy dx. Okay, so you got a choice here, right? You could multiply this out, get some huge polynomial, and take the derivative of the individual terms, or, that would be a lot of work, you can use the chain rule. I think most people would agree the chain rule is best here. So what's dy dx? We start on the outside. You always start on the outside. You got a power, bring it down in the front. So it's 4 times 2x cubed minus 4 all to the 3rd, right? That's the derivative of the outside. Anything to the 4th is 4 times that thing to the 3rd, right? But by the chain rule, we got to take the derivative of the inside. So I multiply this by the derivative of the inside, which is simply 6x squared. Okay? And certainly you can multiply that together and get 24x squared times 2x cubed minus 4 all to the 3rd. Okay, that would be the correct answer. So there's one example. Okay, let's do another example. Number 2. Let's look at the cube root of 1 minus the tangent of x. We'll say theta here. Okay, and we want the derivative once again. I'm just adding these equals y here at the end. Doesn't really matter. The point is, here's a function. What's its derivative? Okay, so let's get dy d theta. And I think, potentially before dy d theta, it can be nice to look at the cube root as follows. You could consider, well, this is y equals 1 minus tangent theta to the 1/3 power. Why write it like that? Well, because we know the power rule, okay? It collects all the roots, but you have to think of it like that. Okay, so now it's much more easier, or at least it's more clear. How do we figure out dy d theta? Okay, we use the 1/3. Bring it down. So we've got the 1/3. That equals, okay, we've got the 1/3. We want to multiply it by 1 minus tangent theta. Subtract 1, that's 3/3, so it's all to the negative 2/3. And then we've got to take the derivative of the inside. So that's times secant theta tangent theta. I'm sorry, that's the derivative of secant. Derivative of tangent is secant squared. So it's secant squared theta. Okay, let me just show you the way sometimes solutions might write this. You should be aware of it. Okay? Sometimes in calculus, students might say, well, I got this, and I check my solution, and it's stating something different. So another way you might see this, dy d theta equals, okay, let's look at numerator and denominator. In the numerator, we've got the secant squared theta. In the denominator, we've got a 3. And then we've got, this would be a positive 2/3. But one way you can express positive 2/3 is you could do a cube root. That's the 1/3 of 1 minus tangent theta squared. Okay, so these are actually equivalent, okay? It's just the way negative roots work. Okay, let's look at another example. Okay, number 3. Okay, let's see if we can go with, let's just look at what is, let's put in ddx of what? Let's go with the natural log of 1 plus x squared over 1 minus x squared. Okay, so what does this equal? Okay, this is going to be interesting. So we start at the outside and we've got natural log of something. That's 1 over that piece. So it's going to be 1 over this. Now, I'll just write it out and then I'll simplify it later. So 1 over 1 plus x squared over 1 minus x squared. But now you've got to multiply that by the derivative of the inside, which is 1 plus x squared divided by 1 minus x squared. Okay, how do we deal with that? That needs the quotient rule. So if my students say, can I cancel out the x squared? Absolutely not. You cannot cancel a cross multiplication, you know. So you just need to use the quotient rule. So we've got to multiply this by the quotient rule. Derivative of the numerator is 2x, okay, times the denominator, 1 minus x squared, minus the derivative of the denominator, minus the derivative of the denominator, that's negative 2x, it becomes a plus 2x, times derivative of the numerator, which is 1 plus x squared. And that's all over the denominator squared, which is 1 minus x squared squared. Okay, now let's simplify this and see what we get. Okay, so whenever you have 1 over a fraction, I like to think you have one numerator, one denominator. That's your numerator, sorry, your numerator is 1, there's your denominator. That means this is in the numerator. Just move it up. Okay, so this is going to become 1 minus x squared over 1 plus x squared. And then here you can actually factor out a 2x, okay, right? You get a 2x in common. So you factor out a 2x. And what are you left with? You're left with 1 minus x squared plus 1 plus x squared, okay? So that's nice because those are going to cancel out, and you've got this 1 minus x squared squared in the bottom. So one of those cancels out, okay? So, right, so one of the 1 minus x squareds will cancel out. You can maybe write that here. One of these cancels with one of those. These two terms are going to cancel, the minus and the plus. And then what are we left with? Well, if we look at the numerator, that's 1 plus 1 is 2, that's 4x, just 4x, over 1 plus x squared times 1 minus x squared. Okay, we're to the y's. You will get good at algebra by doing calculus. Okay, so there are several examples. Let's see if we can squeeze in 1 or 2 more. Let's mix it up here. Okay, how about just a straightforward, let's go with number 4 here. Let's try 1 minus the root of 1 minus e to the negative x cubed. Okay, so if this is equal to y, or it could be anything, let's do y dx. Okay, you can even just write it as y prime when there's not another variable to consider if you know what you're doing. So, okay, it's all to the 1/2, kind of like this was to the 1/3. So what's going to happen is, we'll start to get used to this. You bring down the 1/2, right? That's clear. But then this root is to the negative 1/2, right? Now it's to the 1/2. When you subtract 2 halves, it becomes negative 1/2. And what's a negative 1/2? It's a root in the bottom, okay? So you could just write it to the negative 1/2, or you could say, well, it's going to be 1 over, which is going to be multiplied by something, the square root of 1 minus e to the negative x cubed, right? That is the outside of the function. Now I've got to take the derivative of the inside of the function. Well, what's that? Okay, I've got a negative e to the negative x cubed. What's the derivative of that? Well, it's 1 minus that. It's simply the 1, right, derivative of 1 is 0, so it's going to be negative e to the minus x cubed, okay? Times, it's like a triple chain here, times derivative of what's to the power, which is going to be negative 3x squared. So the two negatives will cancel out, okay, to make it positive. And so you're going to have e to the negative x cubed times that 3x squared. Okay, so that's what your y prime should be. And by the way, you don't have to put these roots in the denominator. You often see them. Totally fine to leave it like to the -1/2, same thing. Okay, I think we can get one more in here. All right, how about number 5? Let's see what we've got here. How about the sine of, and then now let's go with 1 minus e to the -2x. 1 plus e to the, let's just keep it the same, -2x. Okay, similar to this one, so get a little extra practice. What's the derivative? Okay, set it equal to y again, and we'll just go with the y prime here. Okay, on the outside, we've got the right derivative. Sine is cosine, so you get the cosine of this thing, which is, just leave it, 1 minus e to the -2x. Times 1 plus e to the -2x. But now I've got to do that chain rule thing again. Okay, so kind of a pain, but let's do it. Quotient rule, we got to do both. So what's the derivative of the numerator? It is simply the derivative of the second term, right? The 1 is 0, and that's going to be, it's going to be like -e to the -2x times a -2. So it's going to be 2e to the -2x times the denominator, which is 1 plus e to the -2x. And then we've got minus the derivative of the denominator. So that's going to be you got to be careful with your negatives and positives. So when it's minus, right, it's going to be similar to the first one. It's going to be e to the -2x times -2. That's going to make it another plus 2e to the -2x times the numerator. So that's 1 minus e to the -2x. And that's all over the denominator squared. And I will leave you this one to practice simplifying on your own. Okay? I want to show you one last thing with the chain rule. Let's just look at the following. So, dy dx, what is this equal to? By the chain rule, this is kind of cool. So, you can sort of write, you can write it like this. If you put the dy here and the dx here, you could stick in another variable. And you could put a du here and a du here. Okay? This will work. And here's the general idea. These are all differentials, and differentials are very small sort of units. They're kind of like infinitesimally small, right? It's not delta x, okay, where you have like x2 minus x1. It's as x1 approaches x2. It's as it collapses to a point. But you can sort of think of them like variables almost. And note that in this case, the du's would cancel out. Like if this was just a over b times b over c, the b's would cancel out, and you'd be left with a over c, which in this case is dy dx. So you can totally use this. This can show up in applications as a way of sort of using the chain rule. Just to show you how it could look with more, you know, pick your number of variables. Okay, so you could have dy du, but then you could pick another one. Maybe you've got like du dh and so on. But you have to conclude with something like dh dx. Okay, so this is just another way of looking at the chain rule. For practical purposes of doing calculus, what you need to be able to do is really take the derivative of any given function, and it is very common that you will see these functions sort of nested together. Okay? So practice, that's the only way that you will get good at this. Okay? I promise you that. You're not going to get good at calculus just by watching, attending lectures, and reading. Those things are all very important, but the way you get good at it is through practice. It's from making mistakes, learning how to correct the mistakes, and then you get better.